I recently purchased this machine and imported it direct from China through Resin Machinery. They asked me if I would do a video for their marketing department, and I thought, yeah, sure, why not? After all, I was a little bit hesitant buying the machine direct from China since they had no presence in the US, so I figured I would go ahead and make a video so that way if you're thinking about importing a machine, you can have a little bit more confidence that, yeah, you do get them and people in your own country are buying them. So I am in Central Florida. I'm a small sheet metal manufacturing shop. I'm not a reseller yet, but that might change. I don't know. I purchased this machine direct from China back in November of 2024. I got it in about the middle of February 2025. I'm currently recording this about April 9th or 10th, 2025. So right now, hopefully the trade wars are about in the middle. Currently, I paid 30% tariffs, 25 plus 4.4. Right now they're 125, so hopefully that will come back down, I hope. In the meantime though, I thought I would do a accuracy test and demonstration to show the features of the machine. Most of the time, the reason for servo-driven machines, the reasons given for why you would want one are you don't have oil, lower maintenance, you use less electricity, and those are all good, but the two features that I wanted were speed and accuracy. Those are the two that matter to me. I make very small parts, so they have to be very accurate, and I make a lot of them when we do make them, so cost per part is very important. So we're going to go ahead and jump a little bit closer now and take a look at the machine. So here's the setup. We got our program name up here, 18 gauge test. This is how many steps are in it. I'm only making a single step component, so it's just one of one. This is the top punch, so you'll select the top punch from the menu. Oops, that's the wrong thing. So I think you tap on the, okay, yeah, you tap on the icon. So these are the different ones that I have. This is the 0.4 radius, 4.5, and 5.5 millimeter radius tools. We are using that one today. So that's all you do for the setup. Die is the same deal. You select the icon and then you'll select which V die you're running. I'm using the 8 millimeter because I'm doing like I think it's 1.2 millimeter steel, so it's a little bit on the sharp side, but I don't want to do the 12 millimeters, a little too big. So you select your material. In this case, I've renamed this one. It originally said iron. And for some reason I can only get 2 characters. I got to figure that out, and this is probably incorrect. I don't quite know how to set these up yet. I'm still working on that. So thickness, 1.2 millimeter thick steel, as I said before. I'm using an angle compensation of 5.4, probably due to the fact that this material is not set up right. I'm going to chalk that up to user error, but it's pretty easy to adjust. 90-degree bend, 20 millimeter leg length. And what we care mostly about is consistency. You can adjust anything in. I did this in about 6 parts. I dialed in the test piece, and you could get more fussy with that if you want more accuracy. What we care mostly about is consistency. So let's go ahead and make some parts, about 4 of them, and we'll compare part-to-part accuracy. The parts we're running are 18 gauge. I made these actually years ago. They're weld tickets, so I engraved a number on them, so I know that they're all facing exactly the same way, and the laser burr is facing up. All right, here we go. In case you're wondering what the finger guard does, stops the machine in case something interrupts it unexpectedly. Now, if I were to have my hand in it in the first place, it just goes down really, really slow. So this first setup, this is a height gauge. I have zeroed it using gauge blocks to 20 millimeter. I know it's an imperial measuring device using metric values. I know it's a little bit confusing, so this is thousandths of an inch. So what we mostly care about is consistency. So that is about 1.5 thou negative. Next one, 1 thou negative. half a thou negative, and 1 thou negative. So total deviation is 1/1000th of an inch across the 4 parts I measured. All right, so this next setup, this is a Mitutoyo half thou indicator with a magnetic base on a soft jaw, a steel soft jaw I have for my milling machine. And this is set, I think it's 0.573 away from this edge. Now the reason for that number is every 1,000th of an inch is a 1/10 of a degree. So this is going to show some deviation because this is insanely over the top accurate way of checking angles. And then I used a machinist 90-degree gauge to zero it at the 15. So the 15 is exactly on 90. And what we're more interested in is consistency over exactly on 90 because you could just adjust it more. So that is that an overbend? Okay, so yeah, that's an underbend of 0.15 degrees. So that is basically dead on. I mean, that is, 0.05 degrees off. That's almost nothing. Okay, so this one's a little bit more off at 0.25 degrees off. So, I mean, these are not even 1 entire degree off of accuracy, and this is 1/10 of a degree off. So the total deviation was like 3/10 of 1 degree on material that is not super clean on an air bend. So I would say that is pretty darn good result.